Thank you for joining Community Planning Conversations today. We're going to focus on the issue of environment. It's in the news, it's in the recent Time magazine, the recent Atlantic, it's on the news all the time. So I've invited Bill Sullivan, who is director of the Environmental Council at the university, to join me in this conversation. Bill, thank you very much for coming and spending time with me. Before we get into the depth of all of these issues of the environment, how did you get so interested in it and have this incredible expert knowledge about all of these issues?
Well, thank you, Patsy. I have a long history of being interested in the environment. As a child, I loved the outdoors, and I worked for a landscape contractor from the time I was 13 years old, all through college. And in that process, I came to experience how important it is to have a connection to the outdoors and to live in everyday contact with nature. And that's kind of snowballed over the years to widen out to a whole variety of interests with respect to the environment.
Why don't you just briefly explain to our viewers the research that you did for your dissertation and then carried on with, and looking at how people respond to outdoor space and the issues connected with the design of outdoor space, because that's certainly very interesting. It should be for our viewers.
Oh, thank you. Well, for my dissertation, I looked at how people react to various kinds of development at the rural-urban fringe. The fringe is, in many cities, is a place of incredible growth and development today. And a lot of that growth is happening in fashion that's not very environmentally sensitive. A lot of leapfrog development, a lot of development that takes up considerable amount of natural resources, more natural resources than is necessary. And we looked at, I was at the University of Michigan at the time, and we looked at growth and development patterns at the fringe in rural Washtenaw County, right outside of Ann Arbor. And what we found is that if it's properly designed, people actually prefer more dense cluster kinds of developments, as long as it doesn't look like apartment buildings, that preserve a lot of open space, green space, natural amenities, trees, certainly stream water corridors that look actually like streams and not like drainage ditches.
They've been covered with concrete like the boneyard.
Right, right. And that research led to a job here on the faculty, and since then I've been looking at a variety of ways in which people respond to their local environments, both contact with nature in terms of everyday spaces where people live and work, and I'm also interested in helping or understanding how normal human beings, local citizens, can have more of a say, a more effective say, in decisions about their local environments.
But you had a very unique way of going about gathering this information by showing the people variations of how an area or a scene could look as you used computer programs to sort of alter the picture of the scene.
Right. That's a technique that we've been using for some years now, and it's really a wonderful way to engage local citizens, individuals who are not necessarily experts or don't have master's degrees in architecture or civil and environmental engineering or landscape architecture, and help them understand a whole range of possibilities about how an environment may evolve or change, or look at public policies. How might a zoning change or a policy that's related to density, for instance, impact a neighborhood? And the idea is simply that you use computer technology to take digital photos of an existing situation, and then to manipulate those photographs to show how that setting might look under different policy or design guidelines. And then you can use those photographs to engage people, to ask them to look at it and give you their reaction, or you can actually do surveys to make sure that the ideas are sent out to a much larger number of people than who might attend a public hearing on a Tuesday night at 7:30.
Right.
And the other good thing about it is you can get really high quality data back from people. One of the bad things about public hearings is that you often learn about what people don't want. We don't want this, and we won't accept that, and we don't want this. But at the end of the public hearing, it's oftentimes difficult to understand what people actually do want. What do they favor? What are they enthusiastic about? And this kind of process in which you show people a range of possibilities allows you to collect careful data about what they're really enthusiastic about. So that's a very nice tool for planning.
It's a
and
very
design.
nice tool, and actually, I had a reason for asking you about this because this is something that neighborhood associations could very easily do with digital cameras and send people out and take pictures of the neighborhood and then come back and have a neighborhood meeting and talk about how they would like to see things changed a bit. So it has many applications down the line. Now, you were talking about that area between where the city ends and where the rural begins. This is a wonderful lead in to the next part. Just last night on the campus, James Howard Kunstler gave a talk, and an author who has been writing for quite a few years about these issues of the environment and the fact that we are now past the Hubbard's peak on oil availability and such issues of that. And he did talk about what you were talking about is the confusion people have because of the way sprawl is developing, that they don't see that fringe anymore. There's no clear demarcations. What are some of the issues that the environment plays into that, and how can we start corralling it? You just mentioned some policy, some zoning.
Well, yeah, and I think there's environmental issues. There's issues related to the provision of municipal services, providing water for people, providing sewer systems, connecting to municipal services, providing police and fire services out kind of at the edge. So there's a range of kind of fiscal policy and environmental issues. One of which is that we really need to question how much land a single family should have. You know, probably the least efficient development
Are
type.
you talking about just the land alone or also the size of their houses?
Well, let's first just talk about
Okay.
the land alone. Probably the least efficient development pattern that we've got today is this 5 and 7 and 10 acre lots. That those kind of lots, that kind of development means that there's a lot of land associated with each parcel, and then any sewer line or electric line or telephone line or any water line, gas line that you supply means that you're going to be taking up. You'll be having an increasing expenditure because the houses are so far apart. The other thing that does is that typically people use up more of that land. They cut down more trees, or less of the land is actually in kind of a productive, healthy ecosystem when you've got large lots like that, and you haven't really set aside any. A much more effective way, environmentally healthy way to do that is to take the same land, let's say a development of 160 acres, instead of putting it into 5 or 10 acre lots, sell people relatively small lots, and then preserve a large portion of that as green space that everyone has connected, or every house is connected to, where you can have natural looking streams, forested areas, wildlife habitat, produce opportunities for cooling in the summer, protection from the wind in the winter, opportunities to look at wildlife all year long. You can actually create very lovely, wonderful places to live and produce environments that are much more healthy and sustainable in the long run.
And compact.
Right.
Very compact, a bit of density to it. We've talked a bit about what your interest is in your research, and now I'd like to have our viewers learn a bit about what the Environmental Council at the university is focusing on. What is the purpose?
Oh, the purpose of the council is very clear. It's our mission to connect the academic enterprise, both in terms of teaching and learning and also public service, to questions of sustainability.
No, define for everybody how you use sustainability.
I think about sustainability as, we can use the very traditional definition, which is how can we manage our lives today so that we are living comfortable and well, but also doing so in a fashion that doesn't harm future generations to do the same thing. And so that's a fairly broad and encompassing definition that says we need to take a look at how we use all kinds of resources that are limited and finite, and do it in a way that means that in 5 and 6 and 12 generations from now, we haven't used those resources in a way that harms the capacity of our great grandchildren to make reasonable, sensible decisions about how they're going to use those same resources.
Now, some people argue that the way we're living presently on this earth really will take 4 or 5 Earths to sustain us in the pattern in which we're living. So it's not only...
Not only did they argue that, they have very clear and convincing data to support that.
Okay, I was waiting for you to say that. So let's talk about not just that sustainability aspect, but how are we going to start backstepping a bit in the way we presently live, to live still comfortably, but pull back on all the carbon that's going into our air and the sprawl that you just talked about, the size of lots, size of houses.
I think this is a crucial question. It's one of the most fundamental and compelling questions that we face in the 21st century. When you look at what demographers are saying about the increase in global population, you know what they're saying? They're saying 9 to 10 billion people on the face of the earth in 2050. So in 45 years, we're going to have 9 to 10 billion people. And you know what? All those people are going to want to have the same or some level of comfort with respect to heating and cooling. They're going to want to cook their food. They're going to want to have energy just the way that you and I and our neighbors have energy. The fundamental challenge that we face right now is how do we supply 9 million people with that amount of energy and not overheat the globe or trigger a series of global wars related to oil, for instance. And the way that we need to do that is to start working today and using our local communities or our campus as a laboratory for figuring out how we're going to live comfortably and live well with considerably less energy than we've been using.
Well, then let's talk about some of the research and the results of some of the research that's being done at the university and direct application of that on what you're talking about. How can we integrate this into our everyday lives without threatening our way of living?
Right. Well, there's a bunch of things that we're doing on campus, and we're trying to tie this in with the not only with the research but with the teaching opportunities that we're doing. And we're using the campus as a laboratory for testing these ideas and exploring, but also for teaching as well. And then hopefully very soon we'll be working to communicate these ideas. In fact, we've got the first piece of that coming up here at the end of this month, where we'll be dedicating, do a ribbon cutting on the new rain garden that we've got. Have you heard about the rain garden?
Tell folks where the rain garden is.
The rain garden is just to the south and tiny bit to the west of Allen Hall on campus. And
Near the big grove?
Yeah, south of the big grove.
To help people.
Actually, south of that big detention pond that's on Dorner Drive there. The rain garden is a really creative, innovative idea that's been designed by students in Tony Endress's class and built with the help of facilities and services and augmented with sculptures from students in art and design. The rain garden says, hey, let's do something a little bit different with water. Instead of calling it storm water, as soon as you call it storm water, you think of, we got to get rid of it right away.
Right.
So the storm is
Dirty.
a bad thing. We don't
Dirty.
want storms. We don't want storm water. So we get rid of it. On the other hand, if you think of it as rainwater, well, rainwater seems like a resource, something that you might want to keep around and treat with care. And so the students have designed a rain garden in which the water is kind of collected in a little bit of a low area, and it's allowed to percolate back into the soil and then ultimately into the aquifer over many years. The idea is that we treat it as a precious resource and that we design around it to accommodate it. And the students have designed in not only a change in topography where the land can collected
Sort of
water.
like a bowl.
Kind
where
of
it
like a
can
bowl, except, an interesting shaped bowl.
Right.
And then they put a bunch of native plants around it, so it'll be green all year, or at least most in the growing season it'll be green. The plants are native, and they have the capacity to survive both the dry and wet conditions that are associated with, the drier times of the year. But also, when the rain garden gets inundated with water, it'll fill up. So one of the things that we can do to create a more sustainable society is not to put a whole bunch of water, not to shuttle water away, but actually treat water as a resource and collect it and then be able to reuse it. So around the rain garden now, there's going to be no need to irrigate, for instance,
Right.
or to water.
Or need more underground infrastructure to carry the water away,
Right.
which saves a great deal of money
Right.
on any project, and especially on a campus as large as ours, because that's a lot of underground infrastructure
Right.
there. Is this something that our viewers will be able to pick up some educational materials so that if they like the idea, they can go back to their own property and do this? Will be on the Environmental Council website?
Right, we've got information on the Environmental Council website, which you can get to from the University of Illinois website. Facilities and Services has more information as well.
Okay.
There's a bunch of wonderful books.
Oh, name a couple.
You know what, I can't name a couple, but
Okay.
if you go to Pages for All Ages, a local bookstore,
Right.
you can go in the environment area there, and they've got a number of nice books on rain gardens and water in the garden. And the nice thing about that is it's scaled to it's at a small scale for the homeowner, and it's a nice way of reducing the amount of water that you bring from the outside or from down below into your garden or into your yard. Allows you to capture some water and then use it to water plants if you'd like, or just to create an attractive feature in your yard.
And as I always do, I remind our viewers, they are residents of the state. That means they have access to the university library. And so some of these books you'll find in the city planning library, and some of these you will find in the environmental science library. So you're always welcome to come to the university and look for some of these books. Well, we're talking about water. We're talking about keeping it in the place where it comes down or is formed or drains to. So that leads me into asking a bit about eco-machines. John Todd was on the campus probably now 3 weeks ago, a professor at the University of Vermont, and he talked about the eco-machines that he's been building for decades and the effectiveness of those in cleaning up water. So would you talk a little bit more in depth about that process of cleaning water and what it does for water, the reuse of it, and also again why it saves so much of infrastructure by using that?
I'm glad you mentioned that. In fact, through the Environmental Council's collaboration with Facilities and Services on campus, we're actually building an eco machine or a living machine at Allerton as a way to take care of some of the
for those
overflow.
who from outside our community, that's Allerton Park, which is
Right.
very near Monticello.
Right.
No.
We've got a group of students working with a faculty member to create a series of water holding tanks that actually end up kind of not in a tank at all, but in kind of a wetland. And what John Todd has discovered and has designed, invented in a way, is that you can, using living organisms, and carefully designing these tanks that the water flows into, you can clean water in a way that's incredibly effective.
And when we talk about water, we're talking about
used water, like
sewage
water, right?
Yes. So our viewers understand that this is really dirty water that it's cleaning up.
And you can take it in through a series of 7 different stages. Using live organisms, you can actually produce water that meets the municipal standards that Urbana has, or any other city in the state of Illinois. Very clean
Drinking water.
drinking water. You can drink it, right. And
I just saw everybody cringe, the viewers, at the thought of drinking sewage water.
well, we clean our water and reuse it all the time, right? It's not uncommon for us to do this. We clean water and then dump it back into the surface water system, and then
Right.
some people downstream from us take water out of that surface water system and they use it for all their drinking and cleaning and bathing.
Right.
And industrial purposes. So it's absolutely no different than that. What is different is that we're using natural processes and natural systems and living organisms in a series of ponds that are specifically designed to take various nutrients and chemicals and pollutants out of the water, so that as it moves through this process and finally through the wetland, what comes out at the end is really lovely, pure, clean water.
And the other aspect of the eco machines that John Todd talked about was the fact that they turned them into economic development. That's one of the ponds that he showed that they put koi in that they buy for 75 cents, about this size, and then sell for $10 as they have matured, and that generates about $100,000 per year for that project. And another one where they have built the eco machines to clean the water, they have turned that into producing flowers and vegetables, which then are being sold on the market. So it's a very interesting economic development aspect to it for communities to be thinking about, which is a much different avenue of thinking about economic development than communities usually do focus on. So it's sort of a win-win on two sides of those projects that he was talking about.
Right. I'm just delighted to be able to say that on our campus we're not only exploring these ideas, but we're using the campus and its facilities, Allerton Park, as a way to introduce these more sustainable patterns and practices, and to engage students in the process of designing, building, and learning about these things, so that when these students leave, they'll be prepared to help do this in communities all over the country.
Right, the next generation of sanitation engineers.
Right.
That's very
Not
good.
only sanitation engineers, but students who are in other disciplines as well, in business or in the arts or humanities, or in agriculture, who will say, hey, we did this when I was a student at the University of Illinois. We can do it here as well. We can do it in our community, or we can do it in this situation. And they'll help not only create a knowledge base of expertise for it, but they'll, just as importantly, they'll create a demand for it in the communities that they live and work in.
So I'd like to take this idea of the eco machines to another step and have you talk a bit about the building at Oberlin College that a person by the name of David Orr, a professor at Oberlin, was very involved in, which is a totally sustainable academic building on that campus. How did all this happen, and exactly how does that building function?
Well, David Orr had this vision that they'd create a completely sustainable building, a building that got all its energy from the sun and that purified all of the water that it used. And they did a huge amount of work figuring out. William McDonough helped design the building.
And William McDonough is?
He's an architect. He's a former dean of architecture at Virginia. And he's the author of a number of important books.
Right.
A real visionary when it comes to thinking of buildings as parts of natural systems.
Right, almost cradle to grave.
Well, he wrote the book, Cradle to Cradle, actually. Right?
Cradle to cradle, right.
All right. So the building at Oberlin, the Lewis Center, is a phenomenal structure. It's the first kind of green building in the United States. I'm not sure what percentage of its energy it gets from sunlight at the moment.
Okay.
Very nearly all of it, I believe, from solar panels that are on the roof of the building. It has enormous amount of window space, so it has a great connection to the outdoors. They've been very careful about the materials that they use and that were designed. So the paint on the walls, the upholstery on the furniture, the carpeting on the floor is all designed so that it doesn't produce gases that are volatile organic chemicals that would be harmful to breathe.
And why don't you just briefly explain why that's so important?
That's really important because one of the reasons that we have a lot of air circulation in buildings, and we need a lot of air circulation in buildings, is because we bring a lot of toxic materials into buildings. We design a lot of toxic materials into buildings, from the paint on the wall to the carpeting on the floor, the glue that adheres the carpeting to the floor, to the kind of materials on our counters and on other surfaces. Lots of these materials actually produce gases that will concentrate in the air, and you just don't want to breathe these gases too much. And the way to deal with that is to have an air circulation system that moves that air through and exchanges that air fairly a number of times during the course of the day. Well, if you design for using less energy to begin with, one of the most important things you can do is to reduce the amount of air that you have to heat and cool. And in order to do that in a safe fashion and a comfortable fashion, so that people actually feel comfortable in these buildings, is to make sure that you don't include materials that produce these kinds of harmful gases. And so the building was designed with that in mind, and they discovered and used paints and cloths and upholstery materials, carpeting materials that do not produce these gases. The other thing that they've done is all the wood in the building is from certifiably sustainable forests.
And why don't you just explain what that means?
That means that they can continue to use the processes in those forests for the foreseeable future. I mean, many generations.
Right,
And
they don't go in and just clean cut it
Right.
out and kill it out as a
Right.
forest.
It really looks like a forest. It has an overstory and an understory that supports wildlife, and it functions like a forest in terms of what happens with water as well, which is very important because in typical forestry situations where you clear cut things, you have real problems with both water and erosion. It will rain hard, and that rainwater will erode the soil, which produces a lot of troubles, and then the water's got all the soil in it, and it produces difficulties there and clogs up the rivers and lakes. So sustainable forestry practices selectively harvest larger trees, and they keep the understory there, so you've got that helps protects the groundwater. It regenerates the forest. It provides wildlife habitat. So there's lots of good things that are happening there. And these are decisions that we can make. We can decide to build buildings like this. In fact, we're building a building like this on our own campus right now. The College of Business building, which is being built right now. It's more than just a hole in the ground. In fact,
Corner of 6th and Armory.
the corner of 6th
If you
and
want to
Armory.
go watch it, go up.
It's
Yeah.
got the steel is up right now. I don't know if
Right.
the steel is all up, but a lot of the steel is
Right,
up.
so when you want to go be a sidewalk superintendent, you can check out the building
Head
of
right
it.
over there. That's an exciting building. It's going to be a green building, and using the green building standard called LEED, which is Leadership in Energy and Environmental Design, which is it's a kind of a nonprofit organization that certifies the level of sustainability of various buildings in the country. It's going to be at the gold level.
Oh, okay, I thought it was platinum.
No, it's not platinum. It's going to be
Okay.
at the gold level.
Okay.
We're delighted that it's at
And
the gold
what we're
level.
talking about is there's a silver level, gold level, and a platinum level of the ratings that LEED has designed. And within each of those levels, there are sort of subset levels, and there's certain criteria that have to be met for each level.
Right.
So
So it's going to be a
people
high level.
understand.
It's going to be a very green building. It's going to use 75% less energy than some of the older buildings on campus use on an annual basis. It's going to use 40% less energy than many of the buildings that are brand new on campus use. And the reason it's going to do that is it's designed right from the start to require less energy, to be very well insulated, to use fewer exchanges of air on an hourly basis. It's going to get 7% of its energy from solar panels that are going to be on the roof. Part of the building is going to have a green roof. It's going to be a relatively green site. We're just delighted. It's going to be the first College of Business building in the United States that's a green building. And not only is it going to be a green building, it's going to be at the gold level. I think it's tremendously exciting.
And the architect is Caesar Pelli, who is a world-renowned architect, so that's very nice for the campus. He and his son just completed a green building down in Battery Park in New York City, if you happen to be visiting that city. Is this building going to have a cistern in it?
I don't know. That's a
Okay.
good question. That's a very good question.
Well, they put a cistern in the one in New York,
Uh-huh.
and his son was on campus and gave a lecture about that building. And as it was being built, they discovered the building was much tighter than their calculations indicated it would be. And in that discovery, then they began to size down the systems. Allowed them to size down the systems, which is very rare. They're usually designed to oversize, as you well know. But that was kind of interesting to learn that, and so I wondered if they were going to be doing some of that in this building and using cisterns. And because I want to connect back this conversation about the building on our campus back to the building at Oberlin and the eco machines, because you sort of segued to the building on our campus without talking about the cisterns and the bioswales that are
Right.
around the Lewis building.
Right.
And when you're talking cradle to cradle or cradle to grave, which is some terminology, which I'm sure you'll describe for our viewers what exactly that means when they hear those terms used, how that's being integrated into that building at Oberlin.
Okay, well, at Oberlin, all the water that's used in the building gets collected, and instead of going into a sewer pipe that goes out to the street and then out through a series of sewer pipes to the sewage treatment plant, all the water is collected into a series of containers, I think 7 containers, that have different living organisms in them. And these living organisms, through their normal processes, remove bits and pieces of the pollutants that are in the water. I mean, this is sewer water that's going into these tanks. And the final is not a tank. The final area that the water goes to is a little wetland just outside the building, which has a kind of a natural wetland area with wetland plants and wetland animals, fish and other organisms in the water that do the final process of cleaning that water. And then what leaves there is drinking water quality. I'm sorry to say that the building here that we're building for the College of Business does not have a similar system. And that's, I think, the next big step that we need to make.
Okay.
We've worked with Facilities and Services now to change our building standards, and we're going to be moving to make sure that all the buildings that we build on campus are at the silver level, minimum at the silver level.
Even buildings that are renovated?
I think more than $1 million of renovation, which, on our campus, $1 million just goes like that. So
Right.
almost
Okay.
nearly every renovation is going to be at the silver level.
Okay.
And new buildings will be at the silver level. But there's also kinds of site development issues that we need to grapple with. We've got a design for a redesign for a major parking lot on Florida Avenue, at the corner of near the corner of Florida and Lincoln Avenue, lot
Okay.
F23. We'll be using
Permeable concrete.
permeable pavement. Yeah, various
Okay,
kinds of
explain
pavement.
that
Permeable
to
pavement.
our viewers.
Permeable pavement is well, you're familiar with what would happen if I poured water right here on the tabletop, and I'll do that right now. It doesn't go anywhere. It sits right there, and that's the same thing that happens in most parking lots. The only way to get that water off the table would be to create a slope, and then to have that go into a storm sewer and get that storm water out of here. Well, what we're starting to have a change in philosophy now. We're starting to think of the water as rainwater, as a resource, and therefore something that we might want to retain, and or let percolate back into the ground. So the redesign of lot F23 on Florida Avenue there is going to include permeable pavement, which will have holes in it actually, and be porous, and the water will actually be able to seep into the pavement or through the pavement, and then into the soil below it. Some of the water, because sometimes it rains very hard, some of the water will run off and actually run off into a bioswale. Now, a bioswale is a really interesting design feature that it's like a rain garden. It's an area that can collect the water, that has a little bit of a dip or a swale in it, that can collect the water from after it rains. And it includes a whole variety of plants that both live well in the water, but also have the capacity to remove some of the pollutants from the water, so that after the water seeps into the ground from there, it has a little bit less of the oil and other kinds of gasoline and other kinds of things that end up naturally in parking lots. So this is one of the things that we're moving, and we're moving in the direction of making as we resurface our parking lots, we're moving in the direction of having that be a campus standard as well.
I'm so glad to hear that, because they just laid new concrete in the building where my office is located, and it was solid concrete, not. And for our viewers, what this porous concrete looks like, just think of a real natural sponge that you might see if you were snorkeling in the ocean. It looks just like that, except it's going to be gray and not be spongy, but it does have those holes in it. And literally, when Bill poured the water here on the table, that water would have just percolated through that into the ground. And if you ever happen to be over in Bloomington Normal at Illinois State University, they have had a parking lot paved that way for, what did we learn, at least 3 years ago. Bill and I attended the Lieutenant Governor's symposium on green construction for higher education and saw some examples of this concrete at that. What are some of the other things we learned at that conference that we ought to be bringing to the university?
Well, one of the things we talked about at that conference was the use of green energy or renewable energy, and we're making a big effort in that direction here. We've, through the leadership of the students who actually taxed themselves $2 a student per semester, they've collected enough money in a fund called I don't know if it's called the Renewable Energy Fund or the Green Energy Fund, but it's maybe it's called the Clean Energy Fund. I'm not sure which. But the students put together a proposal to allocate some significant portion of that money towards the purchase of 3 wind turbines. And a number of us wrote a grant proposal to the Illinois Clean Energy Community Foundation, and that proposal was funded. The Clean Energy Community Foundation is going to provide $2 million to, in addition to the student money, and then the chancellor, in his wisdom and good graces, provided money to complete the project. That's going to be about a $5.7 million effort to produce 3 wind turbines that are going to be significant in size. They're going to be 1.65 megawatts each, which, if you're like me, you have no idea what that means. What it means is that together the 3 turbines will produce about 3% of the electricity that we use on campus annually.
And they're going to be located where?
They're going to be located on the South Farms, just east of Ray Street, I believe, east of the current cattle facility out there.
And in case you haven't seen any of these wind turbines or a wind farm, and you happen to fly out of the airport in Bloomington Normal as the plane banks in and out, you can see the new wind farm that is now up and functioning.
There's many,
not far from us.
I flew into Bloomington on Monday evening, and there were many dozens of wind turbines there right now. And it looks like more are under construction. So I saw a lot of posts that had no turbines on it.
Sure.
And the posts were at, some of the posts look like they're 10 feet tall, and others looks like they're 200 feet tall. So there's clearly, they're still building, I guess.
Right. I think it's going to be, 120 to 150 turbines on that particular wind farm. Had not intended to bring this up, but now that we're talking about wind turbines, a former student of mine who is from England and saw her about a year ago, and she mentioned that in the United Kingdom, they're going away from the very tall turbines to much shorter, what they call domestic turbines. Mm-hmm. Is this something that's happening here in this country, so that I might have a turbine right outside my home and I can be totally off the grid and my neighbors won't complain?
I'm not sure that you'll be able to be totally off the grid, and I think most of the efforts that are moving in this direction are in Europe at the moment. These are much smaller turbines that they can actually install on your roof, and they would
Right.
generate some portion of your electricity. I'm not sure that you could be off the grid with a turbine like that. Off the grid means that you're not connected to the electrical power grid, and that you'd get all your electricity or power needs from a wind turbine in your yard or on your roof, solar panels, for instance, or geothermal heat pumps. For some reason, we're not there yet in this country. I'm not sure why, but the technology is moving such that we're getting increasingly efficient turbines developed with many different shapes. Some of them are not the windmill patterns, but some of them are. They look more like egg beaters.
Oh, okay, I haven't seen those.
Yeah,
Right.
and well, our friends in Europe are paving the way in this.
Our friends in Europe are always ahead of us a bit.
With respect to energy, they
With
sure
respect
seem
to
be.
energy. Some of our viewers may not know, though, right here in Illinois, we have the solar capital of the Midwest in Stell, Illinois.
That's right.
And that community, which is just slightly south and west of Kankakee to mark it on the map, it's a community totally off the grid. They'll just define what that means, off the grid. They're not connected to any outside source for their energy, and they exist on solar and wind completely for their phone, their homes. How do those people do that? Have you visited Stell?
No, I have not visited Stell.
Okay,
so.
there's a field trip for
Yeah,
our
right.
students and us to go to Stell. They do have open houses every fall and spring, so if people are interested in searching for that on the internet, it's spelled Stell. It rhymes with Bell, and it's Stelle, Illinois. And it's a very interesting community, and it's a good example because most people think we don't have enough sun here to use the solar, but you just mentioned there are going to be solar panels on the new building on the campus, so obviously that's not the case.
Oh, I think the solar technology is advanced to the point where we're really making, you can get a lot of energy. It's capturing a lot more energy than it has in the past. And we need, there's more work being done all the time.
Oh, it's
They're getting
groundbreaking.
increasingly efficient.
They are indeed. Well, some of the other things that we saw at the Lieutenant Governor's Conference, one university went in and changed all of the shower heads to low flow. Is that something the university is going to do?
Well, I think we're moving in the direction of looking at all kinds of things to do with respect to how we use water and energy resources on campus. If you unfortunately, if you go into the new Cersei building, you'll notice that I call them the water waster shower heads instead of the low flow. They're
Cersei means, for those who don't know, that's the physical fitness building on
Yeah.
campus.
But we're redesigning the large intramural physical fitness building on campus. It's some $60 or $70 million renovation, and I understand that there's going to be a lot more energy efficient shower heads in that building.
But they're not going through all the dorms and changing shower
Not-
heads like that other institution did.
Not yet, but you know what we are doing is there's an area on campus called the Six Pack. It's a series of
Right across
three-
from the IMPE building
Yeah.
to market for people.
what is it, 3- and 4-story dormitories,
Mhm.
and that area is going to be completely. Well, those buildings are going to be torn down, and new buildings are going to be built. And the first building that they're building, which has recently been approved, I think, by the Board of Trustees, is a very significant cafeteria building. And that building is going to be very energy efficient, water efficient. It's going to be a green building at the silver level. And it's going to be attached then to, I think it's going to include some dormitory rooms for students with physical disabilities, especially
Okay.
wheelchair students who are in wheelchairs. And then over time, that whole area is going to be redesigned.
And they're going to tear down the buildings?
and-
What about all the embodied energy in those buildings, Bill?
You know, we talked about that, we discussed that, we pushed it, and the chancellor wanted new buildings there, so that's what we're going to have.
And for people who've watched a lot, they have heard the term embodied energy, but maybe there are a few new viewers. So why don't you explain what we mean by embodied energy when
Well-
we talk about this connected to tearing down buildings?
Well, let's say you have an old brick building that's existing there, but the functions don't serve the use that you'd like it to have today. And you decide, well, you're trying to decide, well, should we kind of redesign and reuse the building, or should we tear it down and do something new? And this is actually a discussion that's very current on campus right now. We had the same discussion when we decided to renovate and build onto the intramural building. And we chose to use the current structure. And from an environmental standpoint, that's a real victory, because the bricks are still in place and the infrastructure is there. The building is up and running, and to tear it down and take all that material to the landfill and put it in the landfill, and then go to someplace else and harvest new clay and build new bricks, and then transport those bricks, fire those bricks, and then transport those bricks to the site would be a huge expenditure of energy that wasn't necessary now, because we've decided to reuse the building and design it in such a way that completely fits our use and needs, and does so in a really lovely fashion, and uses the existing resources. So we're using the energy that's been put into those bricks already, and now we're going to be delighted to have essentially a brand new structure.
And actually, it's one of our colleagues at the university, Bruce Hannon, who wrote probably the premier article on embodied energy almost, 30 years ago, an article in Science magazine where he and some colleagues calculated how much energy it takes to produce those bricks and metal and things that go into buildings, and argued that if you took the cost of building new and took the cost of renovating a building, but added to the bottom line of building new all of that embodied energy that would be lost when you tear down a building, then building new is far more expensive than renovating a building, though that's not usually the argument that one hears. Well, there's one last aspect that I want to share with our viewers that we learned about when we were at that symposium, the Lieutenant Governor's Symposium, and it's about the institution that bought all these earthworms to reclaim the food garbage from the various dorms, and how they were using that to recycle that food and then put it back into the earth and then reuse it to grow. Are we going to be doing this with this new facility?
I'm glad you mentioned that. In fact, the Environmental Council has just provided funding to do a pilot project on a major composting effort, so that we're going to take animal waste and also food waste. Animal waste we have about 600 head of cattle on the South Farm, so we're going to take some of that, some of the manure from the cattle. We're going to also look at some scraps from the dormitories and actually create a pilot program to actually compost the food scraps that come out of the kitchen and off of the dinner plates and our dinner, lunch, and breakfast and dinner plates of the students, and then use that to produce wonderful organic mulch.
Right. Rather than sending it to the
landfill
to keep as much out as possible. Well, I hope you've enjoyed learning all of these various ways that the university is engaging in research and actually application on environmental issues. But we do want to leave you with the understanding these aren't things that only can be done on the large scale at the university, that you and I and you can do these at your own home. You can even build the bioswales in your home, put in a small size cistern to reclaim rainwater and reuse that in your home as drinking water or as laundry water and things like that. You know now that you can find this information on the website of the Environmental Council at the university, and you're always welcome to come and use our libraries to pursue them and look at some of the books that talk more about how to do this environmentally. Thank you again for watching Community Planning Conversations, and remember, planning matters.